Okay, so welcome back to our lesson on finding zeros of functions. And now in example 3, we're looking at using a table to find the zeros, or at least approximate where along the x-axis we think they would be. So when I look at this table of ordered pairs, I have x values given in this data starting at -1 and then going all the way up to 5. So I'm going to just make myself a number line here so I can chart what's happening as x goes from -1 to +5. So when x is -1, y is -3, and I'm not going to worry about the magnitude of that. I'm just going to look at the sign of my y values. So at x equals -1, my y is negative. So I'm just going to put a little negative down there. Then when x is 0, the y is still negative. Now when I go from 0 to 1 with x, my y's change from negative to positive. And so we can see there as I trace through here, in order for it to go from negative to positive, there had to be a 0 in between there, right? An x-intercept had to occur for the y values to change sign like that. So that means that right here from 0 to 1, somewhere in between that interval, there's going to be a real 0. So between 0 and +1, right, there's going to be one real 0. Okay, at least one real 0. It could be more, but I know there for sure has to be 1. Okay, now as I continue on, I get at 2, another positive, at 3, another positive, but then at x equals 4, now I'm back down at the negatives again. And the only way I can change signs to go from positive to negative is if I cross the x-axis again, and that's going to be another real 0. So here where we change signs in the y value, right, from negative to positive, gave us an interval from 0 to 1. Now we're going to change from positive to negative here between 3 and 4. So my interval from 3 to 4, non-inclusive, is going to be at least one more real 0. So now there are at least 2 real zeros in this graph. Now when I look at 5 in my x's here in the table, my y is negative, and that takes care of all of the data that I've been given, right? So I can't extrapolate to go on to the left or the right. I don't know what's happening there, but I do know that in between these data points that were given, there's going to have to be a real 0 over the interval 0 to 1, non-inclusive, and another from 3 to 4, non-inclusive. Okay, when I take a look at this second example, I'm going to go ahead and label my number line with the x's from the table of ordered pairs. So starting at -4 and then working my way all the way up to +2. Okay, those are my x values. Now the y values at -4, we have a -55. At -3, still negative at 20. At -2, still negative down here at -3. -1, though, notice we're changing now from a -3 to a +2. So at -1 on my x values, now I've come up here to positives. Okay, then that means that my graph had to start down here, but then bend up, right, to get to this positive value at -1. Okay, now as I look at the next line, 0 is still positive. Okay, then +1, though it isn't a positive or a negative, it's literally 0. So this value, 1, 0, is a real 0. So right here at 1, I'm on the axis. I have an x-intercept that shows up right there, And then at 2, we bounce back up again to positive values. So this curve, it comes up between negative and positive, changes signs from -2 to -1. Then it's going to stay positive, bounce off of this x-axis, and then back up again. Okay, so that's going to be 1 real 0 here at x equals +1. That's the one that we found from the table right here. Then we have an interval, an x interval where there's a 0 from -2 to -1, non-inclusive, right? There has to be a 0 between -2 and -1 because we had a sign change from negative y values to positive y values. Okay, there are no other intervals where there was a sign change from negative to positive or positive back to negative. So this is all I know for sure. I know for sure there's a real 0 at 1. I know that there's for sure at least 1 real 0 from -2 to -1. But then the question that we want to think about is, could there possibly be more? And based on this data that we're given, we can only make determinations about what we see right in here. But if I knew the equation of the function that I was shown, which I can see back here, so my equation is f of x equals x cubed minus 2x plus 1, and this is the graph of that function. And if you look real closely here, you can see there's our real 0 between -2 and -1, right, that we had identified from the table would be in there somewhere. Here's our real 0 at +1, right, that we could see at the table as well. But this is the one that the table did not show us. See how there's a 0 there between 0 and 1 on the x-axis? And that one is hidden from us in this table because it's occurring not between a sign change, but between 0 and that +1 where that real 0 is. So there's no way from the table of ordered pairs we would be able to see that third 0, but we can see these other two. Okay, so there could be more. All we can tell from the table is the least possible number of real zeros. Okay, so go ahead and pause the video at this point and try this problem on some scrap paper or on an individual whiteboard if you have one. Based on this table, you're going to identify any real zeros or give the x intervals between which you know zeros must be located. And then you can turn the video back on when you're ready to resume. Okay, so welcome back, and hopefully you gave this one a try. We can see from this data that at -2, 0, right, we've got a real 0. Same thing at -1, 0, right, so we've got a 0 at x equals -2 and x equals -1. Then there's a sign change here from positive to negative where x is 1 and 2. And so there's a real 0 somewhere between +1 and +2. Okay, and here you can see that table where we put the positives and negatives on so we could chart the trajectory of that curve. There's our two real zeros right on the x-axis, and then here's that third one that we can tell is going to be there somewhere between +1 and 2 in the x